Welcome to CW 3.7. Today we'll be talking about a new concept for all of you. The concept is called limits, like that. So to do that, we're going to first graph this thing. So to do that, I'm going to reduce this, because that would be x plus 2 and x minus 2. That's over x minus 2. That reduces to simply x plus 2. Now all of you can graph that. There's just a line at 2, like this. So you're probably thinking, what's so hard about that? Well, as it is, this is currently not correct, because of right here, you should recall from Algebra 2b, that creates a hole, and the hole happens at 2. So really, to be more precise, we should go to 2 and put an open circle there. And then I'm going to get my eraser and actually make it more clear that it's undefined in there. Like that. So there's our graph. So what we're studying today is called a limit. And the way it looks is like this. The question we're starting with would be, find the limit, so you write lim, x arrow 2 of our original function like this. We're wondering what this would be. Now to do that, I'm going to give you some notation here. So you can just write this down. The key is all in the vocab. That first part means as x approaches a, and I really want all of you to highlight this word approach. I really can't emphasize enough how important that would be. And then the second part, b, your answer, you write f of x approaches b. And again, highlight the word approaches. That is super important. So this question is saying, as x approaches 2, what is this function approaching? So approach 2, so if you imagine you're on this line, just simply approach 2, both directions. Notice how you're approaching the same number, which is right here. You're approaching 4. So you're going to write, the answer is 4. And you can also see that in the table right here. Notice how we're approaching it using these numbers, and we're both sides are approaching the number 4. So let's go to this one. We're going to use a table to find this limit. So I'm going to make a little table like this. And we want to pick a number that's close to 4, because it's all about approaching 4. So if you imagine a number line here, what you want to do is think, what's really close to 4 on the left? So let's pick like 3.99. And really close to 4 on the right, that'd be like 4.001. And let's plug this in. I'll go to my calculator. 3x squared. You want to go to the num button that's right under plot. So hit num like that. And this is a pretty cool feature. You can just actually type it in straight. 3.999 finds it for you. 47.976. So I'll write that in. Now with the other one, 4.001, so just type that in like that. 48.024. So the limit, this thing right here, we can actually write the notation out pretty cleanly. This limit is equal to the number 4. Oh, sorry, not 4. Number 48. Because we can see as x approaches 4, right here, these numbers are approaching 48. And that's your answer. Now you might be wondering, why can't I just plug in 4? Because clearly if I plug in 4, you get 48, and that would be true. And that is true for some problems. Some problems you can just plug in 4, but the key is that that doesn't always work. So while this one it does, this technique of approaching is a technique that works 100% of the time. So if I give you this example, we're approaching 0 now. Notice how you can't plug in 0. So we got to do the approaching technique. So here's 0. On the left would be negative 0.001. On the right, let's pick like 0.001. We're going to make a chart here. And let's plug it in. Negative 0.001, 0.001. Now when you're typing this in your calculator, sine x divided by x, you want to make sure you're in radians. Hopefully you recall from your trig class, you don't want to put this in degrees. So that's why in my top right corner, you'll notice I have pi selected. I'm going to go to number and type it in, negative 0.001, 0.999. And let's type in positive 0.001. Once again, 0.999. So that means our limit, so I'll just copy this thing. Our limit, as x approaches 0 for this function, is 1. And notice how I'm copying the whole thing? That's proper notation. You want to say the limit of your function is equal to 1. Now let's go to a couple graphs here. The limit as x approaches 4 of the function. Notice how I keep saying the word approach. I really want you to do that as well. And what you can do is you can put your pointer on this one, your left pointer, and your right pointer on this part of the graph, and approach 4. So imagine you approach 4. You can see you're approaching this number right here. The limit would be 7. That's different from f of 4. F of 4 is like what we've been doing in the past. You actually evaluate it. That would be 2. Now let's do this one. Use the graph to find the limit as x approaches 3. So let's approach 3 here. Notice I'm going from both directions. The limit is the y value, which is 2. It's not too bad. I do want to point something out here. I want all of you to circle these things here. What's that? Well, that would be called a removable discontinuity. So in 2B, you learned it as a whole. In pre-calc, we call it a removable discontinuity. So that's going to be more formal language. And in your calculus class, they'll probably call it that as well. So essentially, think of it as like a hole and a dot, or it could just be a hole as well. The hole is the most important part. So I'll go to part 2, finding one-sided limits using a graph. So notice on these, you're going to start seeing new notation. There's a little negative right there. Oh, sorry about that. We are right here. There's a little negative right here, a little positive up there. So I got to give you a few notes. We're going to write limit x approaches a with a plus f of x versus the limit as x approaches a minus of f of x. What you want to write is this would mean approach from the right, or the positive side, or the positive numbers. And this would mean approach from the left, or the negatives. So for this one, it says approach -2 from the left. So approach -2 from the left. So I'm only going to stay on the left side. Notice how I'm approaching 0. This says approach -2 from the right. So from the right is going to be here. Notice how I'm approaching -2. Now for this one, there is no plus minus. If there's no plus minus, that means approach from the left and the right. And for this one, since these do not match, you're going to write does not exist. And the last one is going to be -1. and that's because you just evaluate it, and there's a point right there. Now the next thing to point out is going to be, notice this kind of discontinuity here. It's not quite a removable discontinuity. This is called a jump discontinuity because you're literally jumping. So notice how it's like a piecewise function. That's going to be your jump. Now the last part is going to be a bunch of practice here. So I'm going to put the answers, and then you can pause the video here and then check your answers once you're done. Before you check your answers, I'm going to show you a couple things here. Notice how this would be a jump discontinuity. This one is a removable discontinuity. Right here we have something interesting. This one and this one. These are called infinite discontinuities, and that's because they're going off to infinity. Okay, I want to put the answers here, and again, pause the video and then unpause once you're ready to check, and then make sure you ask any questions if you have them for me.